What's up, everybody? Welcome to my YouTube channel. Today we are going to solve LeetCode 199 binary tree right side view. This is a medium level problem and a really fun problem to solve. So let's read the problem. Given the root of the binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. So let's go to the whiteboard. So we have a binary tree here. So we are standing on the right hand side. So we can, from the right hand side, we need to return all the nodes which we can see. So here the root node 5 would be visible. So then the 7 would be visible. So 8 wouldn't be visible because 7 is blocking 8. So here 4 would be visible and here 11 would be visible. So this it cannot this we can also see this problem as we need to return the rightmost node in each level. So this is level 0, which is level 5, level 1 there is 7, level 2 there is 4, and level 3 there is 11. So our result should have 5, 7, 4, and 11. So since we're going level by level, we can use BFS traversal, which goes level by level in the binary tree. So this can also be solved using DFS, which we would look at this after this one. So for BFS, so we use a queue in BFS. So initially we would add the root node 5 to the queue. So and then we would see have the size of the queue. So then we would pop 5 from the queue and see whether it's the rightmost node using the size. So yes, it is. So we would add 5 to the result. So and then we would add 8 and 7, which are the children of 5, to the queue. And then we would pop 8. So now the size would be 2. So we would pop 8. So 8 is the not the rightmost node, but we would still add the child of 8. This is 2. So then we would pop 7. So we would check 7 is the rightmost node. Yes, it is. So we would add 7. So then there is 4, which is a child of 4 is the child of 7. So which would be added to the node, to the queue. So and then we would pop 2 and check whether that's the rightmost node. No, it is not. But we will still add the children of the child of 2, which is 11. So then we would pop 4, we would see that's the rightmost node and add 4. If there is no children, we don't add anything to the queue. And then finally we pop 11 and we see that's the rightmost node and add 11. And once the queue is empty, we come out of the loop. So let's look at the code. So there's a base condition here. So if the root is none, so if there is nothing passed to us, if it's a null, so there is nothing to see. So we return an empty list, so there's nothing to see. So you can confirm this with your interviewer for this base case. So we have so here we need to return a result list. So let's write that down. So for BFS, we are going to have a queue. Queue is going to be a deck Python. So to this queue, we add the root node. So while the length of the queue is not 0 and the queue is not empty, so we take the size as the length of the queue. So now we traverse. So we need to add the rightmost node to our result. So we have this one. Check the size. So before we add this one, we need to pop the node from the queue. So node is equal to queue dot pop left. We pop the leftmost node from the queue. So if this is the right node, we add it to the result array. So if there is a left node, so in BFS we go from left to right. So we add this to the queue. So if there is a right node, so once the queue is empty, we come out of the loop and return the result. Let's look at this. So let's submit it. It got accepted. So let's look at the DFS solution. So for the BFS solution, let's look at the intuition of the solution first. So in BFS, we can use three ways to traverse the tree. We can use pre-order traversal, which is left, center, and right, or we can use in order, which is the root, left, and right. There is also post order, which is right, root, and left. So if we use pre-order traversal, we would look at the left node first. But since we want the rightmost node, so the key here is to use post-order traversal. So once we used post-order traversal, we can look at our intuition to solve. So we'll have a result array, so which we are going to pass in the end. So we would also have so we would start from 5. So we would check if the level of 5 is 0. So the level here is 0. So we would check the length of the result. So level 0 matches with the length of the result. So because there are no elements in the result array, so we will add 5. So then we would see then the at right we come to the right, so which is level 1. So we see the length of the result is 1, so we add 7. So here the level would be 1. So and then there is no right node, so we come to the left. So here the level would be 2, and we check the result of the result array matches with the level, so we add 4. So there is no children for 4, so we go up. So then we go back to the root, and then we go left. So the 8. So here the level is 1, but the length of the result is 3. So we don't add this node. So then we come back to the right. So the level is here, the node is 2 and the level is 2, but the length of the result is 3. So we don't add this node. So when we come here, the level is 3 and the node is 11. So which matches with the length of the result. So we add 11 to the result and return the result. So let's check this. So in this we remove all this queue related. So we are still going to have the base condition and the result. So we are going to have a helper function called DFS. So which is going to do the result. Uh, and we are going to have a level. So if level is equal to the length of the result, so we are going to add the node to the result array. So now the key here is to do the post order traversal. So we do the right node first. So we do DFS of node dot right, and we increment the level by 1. Then we do the left node, and increment the level. So, oops. So we need to call the DFS. Um, so we pass the root node and the level 0. So and we can submit and it got accepted. Thanks for watching.